So first question that is what is given here, that is the steel plate is 30 semi wide and 10 millimeter thick. A rivet of nominal diameter 18 millimeter is driven. The net sectional area of the plate is we have to find out in semi square. Okay, so first what we will see here, that here given this nominal diameter of the rivet that is given, that is 18 millimeter, and after that we have to find the plate hole dia. Okay, for the plate hole dia is, we know that when the rivet is less than 25 millimeter, we for the plate hole dia, that is D plus 1.5 millimeter. So B, here is D plus 1.5 millimeter. Okay, D is also 18 millimeter, so this will be 19.5 millimeter. So we have to find out in semi square, so just take it into in semi square, that is 1.95 semi. Okay, so after that we will be saying the total area of the plate. So area of the plate, that is A equals to 30 into 1. Okay, 30 semi into not 1, 10 millimeter, that is 30 into 10 millimeter is equals to 1 semi, so into 1, so 30 semi square. So we have to find out the net sectional area. For the net area of plate A n is 30 minus, what we will be doing, that we will be taking the plate hole dia, that is 1.95 into thickness of the plate, that is 10 millimeter, that is 1 semi, so 1.9 into 1, so that is it. This is also in semi square. Okay, this whole term in semi square, so it is coming out 29 and after that a 28.05. okay, 28.05, you can calculate it in from calculator, so it is coming 28.05. so this is the answer. So next question, that is a 6 millimeter thick mild steel plate is connected to a 8 millimeter thick plate by 16 millimeter diameter soft rivets, and what is the number of rivets required to carry an 80 kilonewton load. Okay, so first what we will find out, we will find out the rivet hole dia. So nominal diameter of the rivet, that is 16 millimeter soft rivets it is told, so nominal diameter of rivets is given, so we will find out rivet hole dia. So rivet hole dia is, we know that is 16 plus 1.5 millimeter, because it is less than 25 millimeter. If it is above 25 millimeters, then the different value we have to add. So as it is the less than 25, so we will be adding 1.5, so that is 17.5 millimeter. Now just you can see that it is told the soft rivets. For soft rivets we know, for soft rivets the shear strength is taken bearing strength and shear strength. So bearing strength is taken as 300 MPa, and for shear strength that is 100 MPa, as it is soft rivets. Okay, so after that we will be finding out the cross sectional area of the rivet hole dia. So cross sectional area, or you can say the area of rivet hole cross sectional area of the rivet hole, that is A is pi by 4 into 17.5 the whole square millimeter square. So let's calculate it, how much it is coming. That is pi by 4, okay, into 17.5 the square, that is 240.52, 240.528, so 53 millimeter square. So now we will be finding out how much shear force and how much bearing force is coming. Okay, bearing strength you can say also, like force, because we will be multiplying with the stresses. So shear and bearing strength we will be finding out. So just we have to erase it, so let's erase. So for the shear force is that is, we just find out the area of the rivet hole, that is 240.53. so 240.53 into as we know, the for the shear force the shear strength was 100, so 100 Newton per 100 Newton, because this was in MPa. So for MPa we know Newton per millimeter square, and this is millimeter square, so this is Newton. So if it is, we take this by 1000, like if we write it in kilonewton, then this is 24.05 kilonewton. For bearing force, so that is coming out to be 240, again the same 3 into, but we know that for soft rivets the bearing strength is 300 MPa. Okay, so 300 Newton per millimeter square, and this is millimeter square, so this is also in Newton. So this value will be coming out into 3. So this is also, again if we write in kilonewton divided by 1000, so that is into 3, so 72.1516, because 158 is coming, so 16 kilonewton. Okay, kilonewton. So from here after that we will be taking the minimum of these two, because just look, if the sum of the force is crossing, then the first failure will happen, the which in which way the first failure will happen, where the member can carry the less force. So here is the less force is 24.0.5 kilonewton. So the for the carrying for the design load we will be taking for load carry. So carrying for carrying load, that is minimum of these two, it is 24.05 72.16. okay, so that is 24.05 kilonewton. So now we have to find out what is the number of rivets required to for the carry the 18 kilonewton load. How many rivets we have to give so they can carry this much amount of force. So just see. So next see that we have to find out how many rivets are required to carry this load, that is 80 kilonewton load. So the carrying load, so maximum capacity of a load to be safe in both condition, that is for one rivet, that is 24.0.5 kilonewton. So how many rivets will be required for 80 kilonewton, that is number of rivets each 80 by 24.05. okay, so that is coming out 80 by 24.05, that is 3.326. so as it is, you can see that this is coming out greater than number 3. So for to be safe structure fully, so we will be taking 4 rivets, so that will be 4 rivets. okay, so this is the answer. The rivets, number of rivets required is 4. So let's look at this problem. So next problem is a moment m of magnitude 50 kilonewton meter is transmitted to a column flange through a bracket by using 4 20 mm dia rivets. The shear force induced in A means the rivet A. okay, so we have to find out the shear force acting on A. For that, first we have to find out what is the centroid of this whole system. okay, so you can just see that the rivets are equally placed. okay, so the centroid will be in here in the middle because of this symmetrical arrangement of the rivets. okay, so if you see that this will be the centroid. okay, so we have to find out the shear force of the of rivet A. So for finding shear force, first we have to find out the distance from here to the one rivet. okay, let's take it as r. So this is the distance of one rivet from the centroid, that is r. So now we have to find out the value r. So how can I find out the value r? So look that here is given that distance between rivets is 100 millimeter. As this system is 100 millimeter, so this distance will be 50 millimeter. okay, so again this here is told that between distance between two rivets is 100 millimeter. So this also will be also 50 millimeter. okay, so from the we have got this perpendicular distance and this distance, so we can find out this r. okay, so let's find out what is r. So r will be R equals to root over of 50 square plus 50 square, so that is 50 root 2. Okay, that is in millimeter, so it will be in millimeter. So after that they have to find out the shear force in the rivet A. So we know the formula that for shear force in rivet A, for shear force in rivet A, that is, let's take as FA equals to M R by summation of R square. So if you want to know how this formula is coming, so you can follow my class. I will be taking classes of steel structure. So now you can see that R we have found out and M is given, that is M is 50 kilonewton. So just M is 50 kilonewton meter. Okay, so this is in millimeter. Okay, and this is meter. So this will be, if we write in millimeter, so 50 into 10 to the power 3 kilonewton millimeter. Okay, then R square. So just see here that M, that is we have find out 50 into 10 to the power 10 to the power 3 into R, that is also in millimeter, this is also in millimeter, so no problem. So 50 into 50 root 2 by root summation of R square. Just see what is summation of R square, that is the R square value of every rivet we have to add. So 50 root 2 tar whole square plus 50 root 2 tar whole square plus 50 root 2 square plus 50 root 2 square. This is the distance from the every rivet we have just added. That is the meaning of making here, that is the summation of R square. So if we calculate, we will be finding out that 50 into root 10 to the power 3 into 50 root 2 by 4 into 50 root 2 that square. Okay, so from there if we calculate, so it is coming out 50 by 50 root 2 square, that is 0.1 divided by 4 into 1000 into 50 root 2, 176.776, 176.776 kilonewton, because this was in kilonewton, so this will be in kilonewton. Okay. So the next question is told here that the minimum pitch of rivets in a row is recommended as the diameter of the rivet times. So they are asking between the distance between two consecutive rivet. That distance we know as pitch. So we know that for the steel structure we follow the code IS 800. So from there we can find out or say that the pitch distance, we generally minimum pitch distance we take as 2.5 the diameter of the rivet, and that diameter is the nominal diameter of that rivet. So according to as per IS 800, you can write the year also 2007. So the minimum pitch distance between two rivets is 2.5 d. What is d? D is the nominal diameter of a rivet. The nominal diameter of rivet. So you can see this question has come in GATE. So this is a short question, just you can remember that, and this is the answer. Okay. So the next question, that is the common assumption that all rivets share equally a non-eccentric load is valid at a load. So look, there is assumption we take that when our rivets are sharing the load, they take the equally load. Okay, but in actual case it didn't happen, because when you were talking about some number of rivets, the outer rivets of the members or the connection takes more stress compared to the inner one. So the variation is not same, or you said constant for all rivets. Like when you going across two rivets, they actually there is variation of stress. It's not the same for two rivets. So but when we take it as assumption, that the rivets takes equal stress, or you can take tell load when if failure is happening. So at the failure load we take the assumption that all rivets are taking equally load. Okay, so it is the at a load when failure occurs. Okay, so the answer is at failure load. Okay, this is the answer. Okay.